NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams. And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
In the realm of science and immense mysteries, the question of what existed before the colossal impact has sparked intense discussions and captivated thinkers for ages. This epic curiosity does not merely challenge how we might unravel the universe. It pushes the very boundaries of human knowledge. Imagine standing at the edge of existence, gazing into the vast unknown, and pondering what lay there before our universe came into being. The event of the Big Bang marked the beginning of history, space, and everything we know. Yet, was there a moment before this? Could there have been a state of nothingness? A calm before the grand cosmic event began? And if this is true, what was that nothingness? Or perhaps, was there something even more mysterious that existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into investigations that challenge our very perception of reality. Physicist Brian Cox, renowned for his insights into the wonders of the universe, suggests that something astonishing might have existed before the Big Bang. He invites us to rethink our understanding of reality and existence. In this exploration, we will break down the science, the theories, and the astonishing secrets that may help us grasp what existed before everything. We will examine ideas such as cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may surprise you, but they could also provide new perspectives on our place in the universe. Prepare to dive deep into a realm beyond imagination, where science meets mystery, and the shadows of the unknown leave experts awestruck and, at times, unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what could have existed before the Big Bang, we must first understand what the Big Bang actually was. The Big Bang, as scientists describe it, refers to the moment when the universe became extraordinarily hot and dense, expanding rapidly to set in motion the formation of all matter, energy, and the fundamental forces. When we look up at the night sky, we see evidence of this fiery beginning, with galaxies spreading out from a central point. But why did this happen? And was there a time before this hot, dense start? According to the theory of cosmic inflation, there was indeed a before. And it was far from empty or quiet. Inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and smooth, much like a giant vacuum. However, this vacuum wasn't truly empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so quickly that it effectively laid the foundation for everything that followed. In a fraction of a second, space expanded at incredible speeds, slowing down only when the energy transformed into matter, particles, and the forces we observe today as the Big Bang. But what was the nature of this energy? Why did it suddenly create the universe, and why did it stop? Scientists propose that this inflationary phase created patches of the universe, with each patch experiencing its own Big Bang. Imagine a fabric expanding endlessly, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests there could be countless Big Bangs and an infinite number of universes. Ours is just one of many. This vast, mind-bending concept challenges our understanding of the universe and leaves us wondering, what else is out there? The idea of nothingness before the Big Bang is speculative, not concrete. Even if we strip away all energy, particles, and radiation from the universe, it would not truly be empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an intricate cosmic framework. Even if we imagine removing these forces, leaving a dead space, the universe would still generate new forms of energy. This alone perplexes scientists, as it suggests that true nothingness may be impossible within our current understanding of physics. Space itself has properties, rules, and constants that prevent it from being entirely empty. For instance, there's something called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a strange hum of activity even in what should be empty space. This challenges our concept of a true void and implies that, yes, even before the Big Bang there was something. A mystery scientists are still striving to unravel. One of the most intriguing theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue indefinitely. Brian Cox describes a vast, inflationary multiverse where universes are endlessly created and continue to expand. Imagine each Big Bang as a spark igniting a new universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This notion of a fractal universe, where each new universe generates its own Big Bang, leads to a fascinating idea. Our universe is just one tiny part of a colossal, infinite system, constantly evolving and creating new worlds. What if the unsettling truth is that there is no before or after, but rather an eternal cycle of universes forming and dissolving? Our understanding of nothingness changes further when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Rather, it is a complex. All associations of energy handle and fill the universe, interfacing with and making all that we notice. These fields resemble subtle seas, with particles acting as waves or disturbances. Even when fields are at their most negligible energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, quickly borrowing energy before returning it. This phenomenon gives rise to virtual particles, substances that briefly exist and then vanish, leaving only a faint memory of their presence. The idea of virtual particles challenges the possibility of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you truly have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes creating transient particles. This persistent activity in what should be nothing suggests that the universe defies our concept of emptiness. The fields and forces persist, filling the universe with a mysterious energy that prevents absolute nothingness. This understanding raises an intriguing question. If fields create particles and particles create matter, might the universe itself have arisen from this nothingness filled with quantum fields? Dark energy, a mysterious force currently driving the accelerated expansion of our universe, adds another layer to this question. Did dark energy exist before the Big Bang? Some theories propose that the existence of dark energy today is a remnant of an energy field from before the universe's development. The properties of dark energy suggest a vast, hidden force that may have existed in some form before the Big Bang. Some theories even suggest that dark energy, in a much stronger state, could have powered the inflationary phase, causing rapid expansion. The presence of dark energy implies that even if our universe were devoid of all matter and radiation, this force would continue shaping space-time. This leads to a profound question. If dark energy existed before the Big Bang, could it have created the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation or even the true origin of our universe? As we explore this possibility, we face the idea that dark energy might not just shape our universe but hold the key to unlocking the mysteries of the multiverse itself. Another hypothesis, cyclic cosmology, offers an alternative to the Big Bang as the ultimate beginning. It suggests that the universe goes through vast cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event but part of an eternal cycle where universes expand, collapse, and then regenerate in a new cycle. This hypothesis implies there was never a true beginning but rather an everlasting series of universes emerging, evolving, and renewing themselves over and over. Cyclic cosmology raises profound questions about time, suggesting that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give rise to our current universe. For scientists, this hypothesis provides a rich solution to the question of ultimate origins, proposing that there is no definitive beginning. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves offer another fascinating concept that could shed light on what existed before the Big Bang. These waves, first detected in 2015, are ripples in spacetime caused by the acceleration of massive objects, such as colliding black holes. Some scientists believe that these waves might have originated in the early stages of the universe during or even before the Big Bang. If true, it could indicate that something happened before the Big Bang, a disturbance or event that set the stage for the creation of our universe. The idea of gravitational waves from before the Big Bang presents the possibility of detecting remnants from a time before time itself. Through our journey into the unknown, we find ourselves at the very edge of what is possible. The universe, with its intricate web of possibilities, continues to expand beyond our comprehension. Was there something before the Big Bang? And if so, what could it have been? As we continue to push the boundaries of science, we approach a realm where mysteries still prevail. What lies beyond our knowledge may remain elusive, or perhaps one day we'll discover that before the Big Bang, the universe was just one stage in an eternal cycle, a continuous march of creation and destruction, where reality, like dark energy, persists forever. As we delve deeper into these cosmic questions, we find that the lines between known science and speculative theory often blur. One of the most intriguing aspects of the universe's origins is the role of quantum fluctuations. In the quantum realm, tiny fluctuations in energy can lead to the creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the universe's fabric could have sprung from a quantum vacuum, where particles are constantly being created and destroyed. The concept of a quantum vacuum does not imply a complete absence of existence, but rather a state filled with potential, where energy is always in flux. This aligns with the idea of the universe being born from a quantum fluctuation, possibly driven by quantum fields that existed before the Big Bang. These fields could have provided the initial spark for the creation of spacetime itself. In this scenario, the Big Bang can be seen not as a singular explosive event but as the beginning of a new phase in an ever-evolving quantum field. Some theories even propose that the observable universe we know could be just one of many bubbles or regions within a vast cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang might not have been unique to our universe but part of an ongoing process of bubble creation within a larger multiversal framework. These bubbles could have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the possibility that the multiverse might not be entirely inaccessible to us. Some cosmologists believe that it may be possible to detect traces of interactions or collisions between our universe and neighboring ones. These traces could be imprinted on the cosmic microwave background radiation or even in gravitational waves, as mentioned earlier. Detecting such evidence would require advancements in observational instruments and technologies, but the idea of finding signals from other universes challenges our perception of ultimate limits. Furthermore, parallel universes open exciting avenues for understanding the nature of reality itself. If multiple universes exist, each with its own set of physical laws, then the very definition of reality could expand far beyond our current understanding. It may also provide answers to long-standing mysteries, such as the fine-tuning problem, the question of why the constants of nature are perfectly suited for the existence of life. If a multiverse exists, with countless universes having different properties, it could simply be a matter of chance that our universe supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another enigma in understanding the true nature of the universe. Dark matter, which makes up a significant portion of the universe's mass, is invisible to our instruments but exerts a gravitational influence on visible matter. Its origin and properties are still largely unknown, yet it could be intimately connected to the fundamental forces that shaped the early universe. Some scientists speculate that dark matter could hold the key to understanding not only the moments after the Big Bang but also the very fabric of spacetime itself. Ultimately, as we push the frontiers of cosmological science, we are exploring not just the universe's past but also its future. The quest for understanding the origins of the universe, whether it stems from a quantum fluctuation, a cyclic pattern, or the mysteries of dark energy, may ultimately provide us with a deeper understanding of the nature of existence itself. This journey into the unknown is a testament to human curiosity and the unending desire to uncover the hidden truths of the universe.